Howdy, students. Welcome back for another installment of Dan Blabbers About Math. Thanks for joining me. So, let's get down to it super quick. So, one of the problems on your quiz, I'll just be honest, is kind of the form where it goes like this. It says, give me a point, P naught, and it gives you the coordinates of a point. We'll say 3, -2, 1. And then it also gives you a normal vector, n. We'll say, I don't know, 2, 4, 6. And then it tells you to calculate the plane going through the point with the normal vector. So in order to do that, the thing that we should remember is that a plane is the set of points x, y, z such that x minus our x value of this point and y minus our y value of that point and z minus the z value of that point, then that makes another vector. So this is the general vector xyz minus p naught. And if we dotted that with n, so we take that and we dot that with n, 2, 4, 6, dot product, then that needs to equal 0. Okay, so let's figure out what that dot product is. So a dot product says we take the x component times the x component. So 2 times x minus 3, 2 times x minus 3, and then we add that to 4 times y plus 2. Plus, and then the z component, 6 times z minus 1. And that needs to equal 0. Well, a slightly more convenient way to write this, if I want it to look like how we normally write the equation of a plane, is to actually distribute each of these in and move the constant to the other side. So if I do that, I get 2x plus 4y plus 6z equals, and then I have 2 minus 3, so that's -6. To move it to the other side, it becomes plus 6. 4 times 2, that's 8. Move it to the other side, minus 8. 6 times the -1 is -6. Move it to the other side, plus 6. And that equals 4. Check. So simplifying the final equation, we get the equation of our plane through the point P naught with the normal vector n is the equation 2x plus 4y plus 6z equals 4. Okay, I hope that helps for that one. Just on another point of reminding these things, and also as a slight homage to my physics background, I just like to introduce these things just in case you haven't seen them. So if we're given, say, a function of time called r, maybe r for radius, maybe not, but if it's a vector where each component is, say, a function of t, so then this describes, like, say, the position of a point in 3 space, so like x, y, z. In physics, if they have a equation for position, then they put a dot over it. So r dot is the derivative of r, and the derivative of position we call velocity. So in physics, you'll see it written this way sometimes, but math, we tend to write v. And then that's just the component derivative. So that is 6t to the 5th, 4t to the 3rd, and 1. If we do it again, our double dot of t, well, the derivative of velocity is acceleration. And then that's just, again, the component derivative. So this is going to be 30t to the 4th times 12t squared, comma, 0. If we did it again, kind of interestingly enough, our triple dot t is equal to what physicists call the jerk. So we'll use a J for jerk. There, 4 times 3, that's 120 t to the 3rd, 24 t, and 0. So interestingly enough, the jerk is actually something we can show with spaghetti. I find this interesting. So if you take a piece of spaghetti, here's a piece of spaghetti, and we slam it down on the table really flat. Oh, let's try that again here. It shatters, and it's shattered into lots of little pieces. So we could actually see, though, that that was it hitting a flat surface, and at no point did it bend, and yet it'll bend this far. So if I bend it slowly, it takes a lot of bending to break, but if we slam it down and it accelerates at a very accelerated rate, then the internal structure can't take it. Hope that helps. Let me know if you have any questions, and see you in the Zoom session.